Hello everyone, this is Muhammad Javed, lecturer of mathematics at International Maritime College. This module is designed for marine engineering students, year 2. My outcomes for the videos are first order derivative and then use it for the location of maximum and minimum points of a function, and then apply the test to a number of problems. What is the first derivative test? Look at this curve, where this curve is generated from and where this curve is proceeding to. This is not our concern. We are going to study the curve at point A and B. Point A and at point B, we have drawn two tangents. Tangents are actually derivative. These tangents are parallel to the x-axis at point A and at point B. They are parallel to the x-axis, so they are equal to 0, and they are minimum and maximum. A looks maximum point, B looks minimum point. At maximum point and minimum point, all the time dy by dx equals to 0, and dy by dx does not exist in other cases where the curve is not smooth, where we see jumps, sharp cuttings, but we are not discussing this case, or we are only using the first derivative case in terms of equals to 0. If we look at the curve, the rate of change is increasing from the left side to A, and then suddenly it started decreasing on the right side of A, and it steadily decreases until B, and right after B it starts increasing. So increasing means positive, decreasing means negative in both the cases. So before A it's increasing, positive; after A it's decreasing, so negative; before B it is decreasing, so it's negative, and after B it's increasing, so it's positive. Look at point A, so increasing and then decreasing; at point B, decreasing and then increasing. So when this kind of pattern comes, first increasing and then decreasing at a point, we will conclude it a maximum point. And if the pattern is first decreasing and then increasing, we will conclude it minimum point. There is an example on page 755. Let's solve it and find maximum and minimum points of the function. So first we are going for a derivative. 2x plus 0 means 2x, and then according to the tangent at maximum point 0, so we take the derivative equals 0, which gives us x equals 0. We can calculate this y value at this point also if we plug in this value in the actual function. So by plugging this in the actual function, we get y equals 0. So the point is 0 and 1, as you see in the graph of the function. The point 0 and 1 is the minimum point. Now let's see this with the help of the derivative test. Okay, this symbol tells that I used rule 3, and let dy by dx equals 0. I gave this reason for 2x equals 0, which means rate of change. Now let's study the behavior of dy by dx in the neighborhood of x. In the left neighborhood of x means for the smaller number than 0, let x equals minus 0.25. You could have taken another number close to 0. You could have taken minus 0.9. You could have taken minus 0.99. It's up to you. but try to stick close to 0 from the left side or smaller number than 0. Then plug in this value into the derivative, which was 2x, so 2 times the value what you consider, then calculate, it comes minus 0.5, so the derivative value is coming negative. Now other side of the x means greater value of x greater than 0, so let's take 0.25. You could have taken another number, but again I will say stick close to 0, don't take bigger number. Okay, plug in this value into the derivative divided by dx, and you see from the left side we got negative number, on the right side we got positive number. So negative to positive, it means this is a minimum point. Now example 7.2, the same situation. First we do derivative, then we take it 0, we solve it, x value is 1, and then y equals 0. So the point is 1 1, and we are going to study the behavior of derivative at this point, before this and after this. We use rule 3 for our derivative, and again 1 and 1 is the point, x is 1 we found and y is 1. We are going to study it. Okay, behavior. So with the same version before 1, so before 1 or smaller than 1 we get 0.9, we plug in the derivative, and the result is coming 0.2, which is positive. Now after 1 we will take a number, so number depends upon you, but stick close to the point where you are going to find the maximum minimum. Then plug in the value what you suppose. This time it's coming negative, so from positive to negative, this time positive to negative. So this is maximum point. This is the second point we discussed, or the first point. You see it later again in the video. Anyways, so this is a maximum point. First increasing and then decreasing its maximum point. And this is the curve. You can see it is a maximum point, and the point is 1 1. Another example 7.3, this is the function is given. So definitely there are 2 points, one at -1, another at 2. So like the previous question, we find derivative. This time the independent variable is t, so dy by dt. Applying rule 3 we got this result. Now we make it equals to 0. Now we solve it for this. After factorizing it, you can use calculator, and this will give us 2 value, -1 and -2. So we are going according to our graph, given graph. Okay, so we are going to calculate one value at -1, another value at 2 by the derivative rule. So let's study first at -1, so before -1 and after -1. So value for less than -1 I took -1.1, and value for greater than -1 I took -0.9. Okay, for the smaller value it's coming 0.31, which is positive, and for bigger value it's coming -0.29, which is negative. So positive and negative. So which point this could be? Yes, you are right, this is maximum point. Now 2, at 2, so in the neighborhood of 2, before 2 and then after 2, greater than 2, for t equal 1.9, and the result is minus 0.29, which is negative. Then for greater than 2, so 2.1, you could have taken another number, and this time the result is positive. So first negative, then positive, it is minimum point. So at 1 it was at minus 1 it was maximum, and at 2 it was minimum in the graph. This exercise, students, you should try it. Hopefully you will solve it easily, and if there are any problem, we will discuss this in online session, and if I have time I will also upload the solution, but I don't think you will find difficulty this time. Thank you. Take care.